Let's take a look at this word problem. Penny's Diner, 2 eggs. I'm going to label that as 2E. Let's think of E as the variable for eggs. With 1 bacon costs $3.15. And 1 egg, or 1E, and 1 bacon cost $2.20. Now you can already see where I'm trying to put these sentences into equations. So let's use this sentence 1. 2E with 1B equals $3.15. And sentence 2, 1E plus 1B equals $2.20. Now, of course, we do not have to write those ones in front of the variables if we don't want to. However, I did just for simplicity's sake. I love that there are ones in front of both of the bacons. So I'm going to distribute a -1. I'm just going to circle them so I can remember that I actually did change them. There we go. And I'm going to add these two equations together using the elimination technique. So 2E plus -1E would give me 1E. I'm going to not write that 1 this time. 1B plus -1B are going to cancel each other out. And 315 plus -220 is going to give me 95 cents. Now, friends, that is how much an egg costs. But if you'll remember, the question asked us how much is the bacon. So remember, equation 2 was 1E plus 1B equals 220. So if we'll substitute in our 95 cents for the egg, we can easily solve for the bacon by subtracting the 95 cents on both sides of the equation. Oops, I didn't line my decimals up too good there. But that will give me $1.25. And this is how much the bacon is. Therefore, that's my answer to this problem.
So moving on to number 32, it's asking us to divide these two factors. And so what we're going to do is we're going to set it up like a normal division equation. So I like to call it a house. So I'm going to make my house and put this expression in underneath the house. 2x to the third plus 5x squared minus 17x plus 7. Put this factor on the outside of the house, so 2x minus 1. We're going to ask ourselves over this first term right here, we're going to ask ourselves, what can we multiply 2x to the third, what can we multiply 2x by to get 2x to the third? So that's going to be x squared. I'm going to put x squared right here. And then we're going to multiply it back. So 2x to the third. X squared times -1 equals -x squared. Put that right there. Now, we could subtract this, but it's much easier to add a negative than to subtract. So this would be plus, and we're going to change the sign to negative. And then this is a negative sign, so we're going to change it to a positive. So you're just changing it to the opposite sign instead of subtracting. So these two will cancel out and get 0. Then we'll get 5x squared plus x squared equals 6x squared. Then we'll move this next term down. So 6x squared minus 17x. So we'll do the same thing again. So 2x times what equals 6x squared. I'll get 3x. Multiply it back, 6x squared. 3x times -1 is -3x. Same thing. This is a positive, so we'll change the sign to a negative. This is a negative, so we'll change the sign to a positive. These two will cancel out. -17x plus 3x gives us -14x. Then we'll move the next term down again. Just do the same thing all over again, right? So 2x times what equals -14x? -7. Multiply it back, so we'll get -14x plus 7. Change the signs. This will become a positive. This will become a negative. And add the numbers. So cancel out, leaves us a remainder of 0. So the quotient to this division problem here is x squared plus 3x minus 7. For number 33, it gives us a value of 8a squared b to the negative 1. And it gives us the values for a and b. So a equals 3 and b equals negative 2. The way we're going to solve this is we're just going to substitute the values for the variables back into this expression here to find our value. So 8, we'll substitute the a value here, 3, and for a, squared. Make sure you put a parentheses because like on this, for the term for b, which is negative 2 to negative 1, this is the value. So we don't want it to be confused with, because you must do the exponent first and then multiply. You would have to multiply it by the negative, which would change our whole entire answer. So make sure you put your parentheses here. So 8, 3 to the second power is 9. Negative 2 to the negative first power. Remember, our negative first power will flip. So you would do the negative 2 would go on the bottom. So you get a 1 over negative 2. Then we multiply it out. So 8 times 9 equals 72. Then we have negative 1/2. 72 times negative 1 equals negative 72 over our 2 here. Negative 72 divided by 2 equals negative 36. There you go.
In this problem, we're asked to find the degree of the monomial 6. Now, degree means the highest exponent. Well, friends, on 6, I don't see an exponent. When that happens, we know that the x, or the variable, is to the 0 power because it's not being written. And we remember that anything to the 0 power is 1. So even though it's not written, we know that the exponent there on the variable would be to the 0, which means that our degree here is 0. Let's simplify this expression with the exponents. I want you to notice that the negative in front is going to stay in front. And then we're going to raise everything in this parentheses to the negative 4th power. So it's going to look something like this. I'm going to have 3 to the negative 4th power. I'm going to have a to the 2nd to the negative 4th power. And then I'm going to have b to the negative 4th power. So let's simplify from there. We know that negative powers go to the bottom of a fraction. So I've got 1 over 3 to the positive 4th. I've got a to the 2nd to the negative 4th. We remember that we multiply exponents when we do a power to a power. So I've got a to the negative 8, and then I've got b to the negative 4th. Let's go ahead and go one step further, moving those negative exponents to the bottom of a fraction. So I've got 1 over a to the 8th, 1 over b to the 4th. And so I've got my negative out here. I've carried it through the whole problem. Notice on top I've got 1 times 1 times 1. That gives me 1. Then I've got 3 to the 4th here. That is 81. And then I've got a to the 8th, b to the 4th. And this is simplified because all of the exponents are positive.
On number 36, it's asking what the simplified form of this expression is. 6x to the negative 5th times x to the 11th. So when we're multiplying two terms and they both have exponents, we will add the exponents on each variable. So in this one, 6x to the negative 5th is being multiplied by x to the negative 11th. So we will add the two exponents. And since this one does not have a coefficient, we will keep 6. So it'd be 6 times 1, 6x, and then add these two exponents, negative 5 plus 11 equals 6. So we get 6x to the 6th. On number 37, it's asking what the degree of the monomial is, and then monomial is 6x to the 5th. And all it's asking really is what this exponent here is. So that's the degree of this monomial. Now, this is super simple. If this were a 4, it would be to the 4th degree. If this were a 3, it would be to the 3rd degree. And since this is to the 5th, it is the 5th degree. On number 38 here, it's asking us what the factored form of this expression is. And this expression is h squared minus 64. This one is super simple. So we'll set up our factoring here. H. And we're asking ourselves what will multiply together to get negative 64, but add together to get 0. So think of all the factors of negative 64. So I'm thinking 164, 232, 4 and 16. I'm thinking 8 and 8. And immediately 8 catches my attention because both numbers will add together to get 0 if you have one negative and one positive. And we'll multiply together to get negative 64. Therefore, so you have 1 negative 8 and 1 8. So that is the factored form of h squared minus 64.